Okay, welcome to the November 21st, 2023 session of Tangerine SDR and Hamside Technical Session. My name is Dave, KV0S, and this week I've been fixing things. I had several things break this week, um, and then I've been trying a few new things. Uh, Testing out some pies I had turned off and want to use them now. So I going back and making sure they all work and things like that. Not much on the radios, although I keep up up to date on Phil's changes as he goes along. So um then next on the list we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. It's been a very busy week. I let's see, where do I even begin to start? So Saturday we got on the air with the students at the University of Scranton. I was there for most of the day. I was hoping to participate in sweepstakes, but I forgot it started at 4 p.m. So instead we just, talked to a bunch of other stations, and then I let the students be on the air at 4 p.m. But we really enjoyed using the station on Saturday. Um, I have good news that the ARDC has also funded our Hamside workshop grant. So we are good to go with that grant. So again, thank you to ARDC for funding that. The NSF program officer has indicated that she is going to recommend the Hamside workshop grant, the NSF one, for funding as well. So that's in process. One of the things that goes along with that is she said, I can't fund it until you get all your other reports in, even though they're not technically due until like January 1st or something. So I am frantically in the process of writing reports for the NSF grants, but I am doing that. So it's underway. The Frontiers paper was officially published. So that is now out. So thank you very much for everyone's efforts with that. It's officially published on the website now. That's a big deal. It was extremely timely too, because I went to the NASA Science Activation Conference last Thursday, Friday, Wednesday, Thursday, Friday, and that's a conference where there's also like a little mini citizen science conference there, and the NASA citizen science program officers were there. So it was really nice to wake up on Thursday morning and tell the NASA program officers that our review paper was just published that morning. So it's very timely. So I think there's a lot of good things that are in progress. So just try to keep going with that, and hopefully I can keep up with all these reports. Back to net.
Okay, next on the list is Phil, K9Q. Go ahead, Phil.
Oh, okay. Let's see, what have I been doing the last week? They're watching rockets, making little changes. The flood of changes has slowed down a little bit to K9Q radio. Most of the changes I made recently have been fixes to permissions and stuff like that. I've added, well, a while ago, I added some FT8 and Whisper skimmers that run independently from Whisper Daemon. I don't know if anybody's used those, but they, if you turn them on, they will run their own copies of FT8 and Whisper decoders, and also log the results in Verilog, which is the standard place that Linux keeps logs. So it's an easy, quick way to see what's going on. It also impresses people to show them all the FT8 traffic on all the HF bands simultaneously, which is kind of fun.
Yes.
Let's see. I think last week, Franco, you and I talked about your new code for setting the clock synthesizer in the
Yep.
888.
Yeah.
So far, that seems to be working fine. If you have no problems with it, I'm just going to make that, the official code.
Yeah, you go right ahead, Phil.
Okay. I
Call it
haven't really tried a
calibrate.
lot.
Yeah.
What's that?
Call it calibrate if you remove the other code.
Yeah, I did remove calibrate since it didn't seem to be any use for it anymore
Okay.
with your stuff. No, I haven't tried a lot of different clock rates, so I'm still only using 64.8. I don't know what kind of errors you see with other, what is the maximum error you see with other clock frequencies, at least ones that people might be wanting to use. But I don't know, what is the actually, how close can you get using your continued fraction?
I saw when I put inside in your number was 1.54 ppms, I got to 0.02 2 or 20 millihertz or something like that of the requested ADC frequency.
Two
Makes
million,
sense?
two, did you
2
say?
milli or 20 milli, I don't remember. I can double check. Actually, if
Okay,
you look,
it's
it prints out. You should see the value.
yeah, that's right. It does. It does. Whatever it is, it's pretty close. I think it's down in the phase noise of the TCXO. So, I mean, that's about basically all you can really hope for. And it seems to be working. I don't have I haven't taken a drill to my RX888 yet, but I've been manually calibrating against my oscillator, my GPSDO, where it leaks into the front end, and seems to work about as well as that can be expected.
I mean, if there is drift over time, it can be a pain in the neck to adjust
Well,
because you have
yeah,
to reconfigure it. So I don't
I've
know.
I've thought about. I mean, yeah, I could make right now. I mean, the only way to change the calibration figure is to edit the config file and restart Radio D, which of course is a pain. I don't know if people would find it useful to make a real time adjustment or not. I mean, all things are possible, but um, let's see what else. That was one thing people talked about as a real time calibrate. Although it may just be that anybody serious about this is just going to eventually connect their their front end directly to GPS and just get rid of the problem that way. Let's see what else. I am thinking about a re-architecting of the interface between Radio D and its users, although I'll be very careful about this not to really break anything. Right now, as you know, a lot of configuration goes into the Radio D config file. You set up a lot of fixed channels, and then you run whatever programs you want to passively listen to those channels. I'm thinking maybe I should go more towards having the client programs actually dynamically set up channels. In other words, when a client starts up, when Radio D starts up, it doesn't really do anything. When a client starts up, it sends what it wants to listen to in the modes, and it dynamically creates a channel, and then that channel runs only as long as somebody's listening to it. I mean, I have that capability right now. I am using it for manual control. Now, right now, I don't think any clients are listening to Radio D output streams other than the ones that I've written, like PCM Cat and PCM Record and so forth. So of course, those would have the necessary changes built in. Is anybody working on anything else that listens directly to a multicast stream from Radio D? I don't know of anybody
Yeah,
doing it.
I have the GNU Radio module GR-RTP. I can send you the link so you can
Okay.
actually, Tom and I have been doing experiments with that.
Okay. But would you find it hard to integrate in in other words, you would tell that program what you want to listen to and what
Yeah, no
sample rate and
problem.
so forth, and then it would send a control command. I mean, I can give you the modules to do it, but I just want to make sure I'm not going to pull the rug out from under anybody if I do this. I mean, you can
Yeah, we can talk
continue
about that
to.
later.
I mean, I'm not going to take out support for fixed channels in KNIQ radio. No reason to do that. But I think it'd be more flexible, especially because I'm realizing now that I really have overloaded the SSRC figure by making it the channel frequency. That's caused some problems already with sites that have multiple receivers on the same frequency. And let's see that. And well, just the kind of inelegance of having radio channels running when there's nobody listening, putting out all that that traffic when nobody's listening. It just seems kind of inelegant. So that's really about the only major thing I've been thinking about. All right, that's it.
Okay.
Back to Matt.
And also, I wanted to mention to you, Phil, we're coming up about 3 weeks to the mini DCC.
Oh yeah.
If you need any help with getting your talk together, let me know.
Okay. How much time do I have?
Generally about 30 minutes, 40 minutes if you want.
Okay. That goes pretty quickly, I know.
Yeah, but we're doing the pre-recorded if that's okay with you.
Okay. For some reason, I don't have a lot of experience in doing pre-recorded talks. I kind of like to do it to interactive audience. I know it's just what I'm used to, but
Well, if you need somebody to be your audience while you're giving the talk, I can be.
yeah. And I'm just
Okay.
used to standing in front of a room, and looking at feedback and knowing whether I'm going too fast or too slow. It's just
Yes,
I'm not used
I
to talking to a soulless camera.
yes,
I agree with that. I think the pre-recorded is much more difficult.
yes.
It is. It really is. You're
Well,
all stopping and saying, "Oh shit, I can do that better," and you got 5 hours of outtakes and 30 minutes of final program.
well, from the other side, I'd like to say that it's awful lot easier to run the meeting if they're all pre-recorded.
Oh, I can understand, but then you have to take questions at some point, right?
Yes. So,
So does that
any,
30 minutes include questions?
no.
Okay.
So, next on the list, we have Jim, B4B BSE. Go ahead, Jim.
Good evening, all. Not a lot to report from here. Still fighting this knee replacement a little bit. Had having some problems with it at the moment, and really haven't been doing anything much with ham radio. My 3 ham sci experiments continue to run. Had apparently a power loss the other day, and I thought I was plugged into a backup power supply, but apparently I'm not into the backup side, so I got to crawl down and figure that out one of these days. But otherwise, not a whole lot going on right now. I'm back to net.
Okay. Next on the list, we have Bob N5BRG. Go ahead, Bob.
Okay, hello everybody. I'm just working on nursing my data along, evaluating data for both magnetometer and the grape units, and also trying to get data running on a couple of other experiments I've got running here, and shepherding the pies, kind of like you said earlier, Dave, about trying to make sure all the pies are working, and it's hard to keep everything running like we want it to.
Yeah.
Anyway, back to the group.
Okay. Next on the list, we have Dave, KD0 EAG. Go ahead, Dave.
Okay, hello everybody. I've been plugging along on things, but I've also I got to where my own mess was even making me crazy, and that's saying a lot. Anyway. So I've had still some other interruptions. So I'm staying busy, very busy, but nothing really to report properly. That's it for me.
Okay. Next on the list would be, to make sure, David, N1 HAC. Go ahead, David.
Good evening, everyone on the net. My excitement this last week was the FMPs, the frequency measurement practices. I did not get on the FMT. Unfortunately, I have a standing conflict with when they seem to run it, but I did have some interesting. I was using my Kenwood TS2000 and discovered it has a 0.7 hertz cycle over 15 minutes. So not very good for doing frequency measurement tests. I'll be looking to use something like an RX888 next time when we start doing that, because I will definitely be running that on GPS. But that's about it over here. Looking forward, so to speak, for a little bit of snow tomorrow night, and then Thanksgiving coming up. So time moving on. So back to net.
Okay. Next on the list is Franco, K4VZ. Go ahead, Franco.
Good evening, everyone. A couple of things I've been working on. Number one is an issue that we'll discuss maybe with Tom later. Where there was a bug in the GNU Radio RTP module that is now fixed. And the other things I've been working on, I don't know if Robinette is here. There was Clint Turner who found some problem with an algorithm to compute from real to complex samples, and he said the frequency is off by a few hertz, but something that is just, I don't think it's there, but it depends how you measure the frequency. Other than that, not much else to report. I'm waiting for the TRX2 to come in so I can play with that soon. Back to you, Dave.
Okay, very good. And next on the list is John, WI6P. Go ahead, John.
Good evening, everyone. I'm a newcomer to the group. I'm here. I'm on the very steep part of the learning curve with regard to all of the grape and related technology that you guys are very much involved in. And I have 3 Grape 1 receivers that I've built up and are operating, 2 of them reporting, monitoring WWB at 10 and 15. And the third one is also monitoring 15 megahertz, but with 2 different antennas. So I sort of have an internal experiment looking at a vertical versus a Carolina Windham antenna and how that affects the data. But I'm really, as I said, very steep part of the learning curve. I'm enjoying listening into these meetings, and I'm learning a lot about the technology that we all love. So 73s back to all of you.
Well, welcome and enjoy your presence, and hopefully it's instructive. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I don't have many. I don't really have a lot of VLF related items to report this week. Other non-VLF related items were pulling my time. So I did an interview with the Rain Report. That's an amateur radio podcast, Radio Amateur Information Network, and it is currently being edited. The topic that I talk about is VLF and natural radio signals, and that will be it will probably be posted the end of December or sometime in January. And it's an interesting podcast. It talks about the basis of the basics, dawn chorus, whistlers, spherics, tweaks, how to listen, what you have to do to listen, just for the beginner getting started, getting into VLF natural radio. And also NML has been going up and down, and Grindavik in Iceland, NRK, well, as some of you may know, there have been some unfortunate earthquakes and seismic activity, and NRK has been offline for a good couple days. So and that's unfortunate, because I would get that pretty well on the system. So it's kind of unfortunate, but with what happened, it's definitely to be expected, and hopefully everyone's able to recover quickly and get back to normal. Hopefully the aftershocks settle down, and everything else. But I've been capturing really good data, but other people have been using VLF-RX tools to capture VLF transmitters. But the problem is that on some of the transmitters, a phase information isn't doesn't work right. And I have to investigate whether they're having issues with GPS, or it might be a bug in the program VTSID, which is what actually does the FFT to monitor the individual VLF transmitter, the signal, the signal amplitude and phase, and you know, just to see whether it's a bug with that, with VTSID, or it's something with GPS. So I have to do some investigation, because that's interesting, because if I'm going to deploy this, I want to make sure that everything works. But so far, I've had good luck with the VLF transmitters that are able to be received at Springbrook. That's all I have. Back to the net.
Okay. Next on the list is Tom in 5EG. Go ahead, Tom.
Okay, good evening. It's been a busy week. Franco has been more than extraordinarily helpful with GRRTP. Franco, I got to ask you, how in the world did you find that bug? I mean, you must have some magic debugging skill or something. That was impressive. Phil, a question. I'm getting a lot of signal clipping on WWV, and in the configuration file, I have AGC equals no on the WWV IQ demodulator. And so after getting clipping, I went in and lowered the front end gain on Radio D. I went to the low gain mode, set -5, set the attenuator to 5 dB. And so I moved the peak reported high watermark signal from about -9 dBFS down to -39 dBFS. And the signal clipping on the WWVD mod did not change at all. Absolutely exactly the same. And so I'm maybe I'm missing something as to what's going on here. Is it just a matter of turning on AGC for an individual DMOD? I would think by changing the RF gain, I would have brought the signal levels down by 30 dB or so.
Yeah, you should have. Well, first thing I'll note is that when receiving an AM signal in IQ mode or an AM mode, there's going to be a DC component. I don't know if you noticed that.
Okay.
That's the carrier.
Yeah. Well, yeah. The actually I have about a 1 hertz carrier because I'm using the RX888 internal oscillator, which is a remarkably a good oscillator on
Yeah,
the
it is.
888.
Well,
so
it's got an oven controlled, it's an oven controlled oscillator, right?
Yeah, so it's good. Let me bring up a slide here, and if I can share screen, and so this is what I'm getting out. If you see the waveform in the center, it clips, at +1 and at -1. And this was after putting in a bunch of RF attenuation in the front. And so I was getting about these same waveforms. And you can see the 1 hertz IQ offset there from the WWV carrier in IQ mode. And the bottom is the spectrum. And of course, the clipping really degrades the spectrum quite a bit. But I was wondering, is there something else I need to be doing on the gain change or do I just need to turn on AGC in the demodulator?
I don't know of any place that should have DC in it other than, and of course, it won't actually be DC. It'll be, 1 hertz or whatever your offset is, or whatever the ionosphere is doing to the signal.
Yeah, as I see the signal fade, of course, it comes out of clipping, which is what you expect.
Right.
But that's when I've tried to add in a bunch of front-end attenuation.
Oh, well, remember now that when you change the gain of the front end, I don't know why I
Uh-huh.
didn't think of this before. When you change the gate at the front end, it is compensated for immediately in the digital domain. The purpose of the front end gain
Oh,
is only to keep the ADD within its happy area.
okay,
Okay. The overall gain from the antenna connector to the digital side
Uh-huh.
should be constant.
okay, okay. So that's my issue then. So
Yeah.
I will have to turn on, if I want it controlled, I'll have to turn on the
Yeah. You should not change
AGC
the
and the
RF
DMOD.
gain. Don't change the RF gain to affect the output. Change the RF gain only to keep the ADD converter happy. That's
Okay,
what it's for.
yeah, in the nominal setting that's default in the HF file that you provided, I'm getting like about -9 dBFS. And
That's a
so,
little hot. You might want to knock it down some.
okay, okay.
Yeah, remember it's a Gaussian signal, so what you're reading
Yeah.
there is the average. And I think I am computing that correctly.
Okay,
I have two different ways of defining 0 dBFS, and for a real ADD converter for a single channel, I define 0 dBFS as a sine wave that is just at clipping, plus or minus 32,767. For a complex signal, I define it as having an amplitude of 1.
okay,
In
okay,
other words, square root of sums of I squared plus Q squared is 1, which is actually twice as much power.
okay. Let
Okay,
me,
so, but
okay.
so that should mean that if you stay below, the rule of thumb for a Gaussian is about 15 dB, right? Peak to average
Yeah.
power ratio. And you should actually be able to see that by looking at the count of overranges now that I actually have it working correctly.
Okay.
Um,
Is
and
there,
I worked out the expected number. I think Franco did that. I saw some math go by where you were looking at the error function, which I was going to do, but I think he beat me to it, to say what the expected number of overranges should be for a given Gaussian average input level.
okay, are the overranges printed on the console?
No, they are because they can happen too quickly. They're a parameter that is counted and displayed in the control program
Oh, okay, okay,
underneath
good.
where it has the total number of counts or the sample counts on the input. There's also a count of overranges there.
Okay.
And I know, Franco, did you finish that analysis? I mean, I saw you do it and I said, oh, he's done. I want to do it.
I have it. I don't know if Tom was in the mail, but I can send it to him. And I think I missed the square root of 2 where I had the sigma in the denominator. It's the usual
Okay.
factor. So I think it's x over square root of 2 times sigma. So I can send it to you, Tom, and maybe
Okay.
actually
It'd be
I
interesting
send
to
it to
see how
Phil too, so
close
he
I
can double
get.
check.
You know,
Yeah.
work out for my definition of 0 dBFS, if you're at say -10, what should the rate of overranges be for a Gaussian input? That would be a nice number to know, just to
Okay.
calibrate the whole thing.
Okay. So I ran the time scale. This is in GNU Radio. I had it parked on 10 megahertz WWV. And the time scale on the top graph is wrong. GNU Radio is way, way off. That's about 3 hours of data on the waterfall at the top. And the frequency display range goes from -8 hertz to +8 hertz. So the 16 kilohertz spectrum is decimated by what, 512 or 1024.
Are you showing a plot now? I mean, all I see is is a folder window.
Yeah, it's this is this is just a static image. Is it showing?
It's
Oh,
not,
I see the directory window. I don't see a,
No.
It's just a thumbnail, Tom.
Okay, let me stop sharing and go back and get the,
maybe sharing the wrong window.
yeah, could be. Let me hang on, let me try and grab the correct window. Good heavens. Okay, is that better?
There we
Yes.
go.
Okay.
Yeah, that's correct.
Much more
Okay.
interesting. Yeah.
So the top scale is about 3 hours of data,
Mm-hmm.
and it's the bright red in the center is the WWV carrier. measured using the RX-888 internal oscillator. And you can see it's, you know, about a hertz off, maybe, not bad. So 0.1 ppm, really impressive.
Why does it split? Is it WWVH?
No, I believe, I'm not sure what the mode splitting is there. It about the top of this, the bottom of the screen, it completely died. There was nothing there. You can see the IQ waveform in the center screen is almost zero. So the band had just about gone out at the very bottom of the water.
Well, I mean, when you listen to it, were you hearing both WWV and WWVH or just one of them?
I was hearing both of them for a while.
Okay, and then you're probably seeing both carriers.
Yeah. So, but definitely the resolution, you can see the white streaks spaced at 1 hertz. That's the 1 hertz ticker on WWV. So you can see the 1 hertz tick. Spectral lines repeat both left and right. The center screen is the oscilloscope. It's just looking at a 1 second snap of the I and Q signals. And then the bottom is the spectrum from -8 kilohertz to +8 kilohertz. And of course, you can see the carrier in there. And this has been filtered a little bit, gets rid of the noise and makes the carrier stand out. But I think it's pretty usable. It's a fairly good display, and I'm pretty happy with what it's doing. So I will go turn on AGC and maybe do some longer term runs. But right now, I think this is starting to provide usable data from the RX-888. I was real happy with it, and Franco's module is working very well.
What's the time scale? What's the scale on the horizontal axis on the bottom? Is that hertz?
That's kilohertz.
Oh, kilohertz.
Yeah, so it's going from -8. So I filtered it just a little bit under 6 kilohertz.
How come I don't see the tones?
Okay, well, the instantaneous snapshot here was just a time period of dead carrier.
Oh, well, they still have ticks.
Right, but with the spectral averaging turned on, all the modulation sort of disappears.
Oh, okay, okay.
If I have, I can show you one. Let me stop sharing this and go to a different one here. Hang on, let me try to pick a good representative one. Okay, now let me try and share again. Okay, here in the bottom, you can see the tones.
Okay.
And they're broadened out a little bit, of course, because of the clipping you see. But on the oscilloscope picture in the center of the display, you'll notice at about the 300 millisecond time frame, that's the 1 second tick waveform. You can see the burst up and down. And then a few milliseconds later, you can see the tone burst, that, you know, the brief tone that they put on the carrier, which stands out pretty well.
Yeah.
And so overall, and you can see if you look at the waterfall, that's a little earlier in time before the waterfall had filled up. That waterfall is maybe 3 hours of display, but it's starting to produce really good data. So I have to say I'm pretty happy with it.
Okay. So is the bottom spectrum, is that my filter, or did you add a filter on top of mine?
I've added a filter on top of yours.
Okay.
Yeah. So this is about, it's around 5.75 kilohertz low pass filter in the IQ, but it's a low pass filter. So it filters from -5.75 to +5.75. So it's a low pass filter symmetric around DC.
Well, my filter by default is ±5. So
okay,
that's the one you should see.
All right. Well, this one is starting to fall off at 5 here. So I played around with
your sample rate? It's
16K.
Oh, 16K, of course. Okay, I'm looking at the bottom. Okay, 16K. But I think my default AM bandwidth is still ±5, or IQ is ±5.
Okay, I thought it was a little higher than that.
Well,
But
take a
any-
look with
I'll go
control.
look at it.
Yeah.
And the top one, I create the top waterfall graph by decimating the 16K stream by a very large number. And I think it's 1024. And then low pass filtering it to plus or minus about 5 hertz or so.
Mhm.
And then that display, so that lets you zero in on the carrier frequency and get the, a little bit more resolution on the carrier frequency.
Okay,
But
and the
that
1 hertz
dissipation-
offset is your local oscillator error?
I'm sorry?
The 1 hertz low offset, that is in your TCXO?
Yeah, that's the offset basically of the RX888's LO.
Got it.
Yeah, Tom, you can use the new parameter calibrate if you wanted to fix that too.
Okay.
Yeah.
Okay. I can see it drift around a little bit as the RX88 warms up slightly. I did the thermal blanket mod. I left the blue film on the blanket so that the stuff would slide into the case well. And the whole case is warm but not hot, and it seems to be the same temperature everywhere. So that thermal blanket seems to be distributing and pulling the heat out of the radio quite well.
Can you then list the part number or catalog number of that foam that you used?
Yeah, it's a $32 sheet of foam, and you need about 1/20th of the sheet. So
Okay.
so I have enough of the foam. It's sticky, but it comes shipped with a blue film, very, very thin film. And I just left that film on and put the sticky side on the PC board. It's a very insulative electrical film. And the blue stuff, once started, slides into the case nicely. So it
Okay.
doesn't bunch up as it slides in.
So that film is there to protect the sticky side on both sides?
No, there's a very heavy clear base which protects sticky on one side, and the blue film protects sticky on the other. So I cut it off, peeled it off of the heavy Mylar clear base, and left the blue side intact. And I put the unprotected side of the thermal stuff down on the board itself, so it's actually the pucky stuff is actually touching all the parts on the board, and the blue stuff is touching the metal case.
Okay, what I'm getting at is I think there's a version of that stuff that has metal film on one side that might even be better for contacting, transferring heat to the case.
Yeah, it might. The blue stuff, which was available on DigiKey, seems thermally to be working really, really well.
Okay, hey, you got some left over, ship it to me, or I'll go buy some,
Okay.
whichever.
Yeah, it's well packed, so it so far so good. At any rate, so that's enough time tonight. It's been working well.
Great.
Back to the net.
Well, I think we're done, called on everybody on the net, so we're open for general discussion.
Michael showed up.
Michael? Oh, Michael, AA8K. Comments?
Greetings to everyone.
Very good.
Sometimes I say other stuff.
Yeah.
Dave Witten.
Yes.
I just sent you an email. Did you see it?
Yes. Oh, well, probably if I look. Yes. Yes, I do see. Yes.
Does that work?
Looks good to me. Looks good to me. So you edited that, and that was their only comment the last time. Well, you probably saw what they said, so I probably
Yes.
forwarded you. Yeah, so that looks great.
Wonderful.
I don't know whether they've certified us yet or not. I haven't. They seem to do this every Friday night, every other week, and so it's not a very fast turnaround. But I thought we might as well give it a go.
I guess so people know what we're talking about. We're trying to submit the magnetometer project to the Hardware X paper, and the Hardware X journal requires us to be a certified open source project, and they did some sort of review and they wanted us to add a Creative Commons statement to the bottom of our magnetometer documentation on the HamSci website, and we did that. So hopefully we're on our way to being certified.
Certifiable.
Very good.
Thanks a lot.
Thank you.
I wanted to, if we have a few minutes, bring up a couple of questions about the Clementine SDR, and these are observation based on what Dave William was saying last week, where basically we found out that of the old design, the probably most expensive component is going to be the ADC, whatever is going to be chosen, and it looks like the LTC 2208 by retail is $140, $50. I forgot how much it is, but you can find much cheaper on AliExpress. So my question to the group is actually, what is your, how to say, take on this? So how much do you think the Clementine SDR should not cost, but should, how to say, be envisioned, compared, for instance, to the RX888 and other devices? What is your take on this? Make sense? No.
Well, if I understand your question, because of the pricing in different countries, parts that essentially function similarly are dramatically different prices, right?
So this is a good question. What I know is that there is a part called LTC 2208, which supposedly is this ADC made by analog devices, which if you go to Mauser or any places here, DigiKey costs probably $140. And for some reason, if you go on AliExpress, assuming the same device with the same quality, costs $15, $20 or so, okay? I don't know exactly why that. That's a $1 million question, okay? And I don't know if but the cost of that piece is going to be the most expensive component of the Clementine SDR, as far as I can tell, because the FX3 costs probably $25. Everything else is much smaller in range. So my question for the group is that if the decision is made to use, the official, whatever official, the expensive one, we are talking about probably at a $300 device or something like that. In the other case, the price will be much lower, but there are, different concerns. So it was more an idea of where you think the Clementine SDR should position itself. I don't know if it makes sense. It's kind of just thoughts on what Dave William was saying last week.
Would it make sense to actually purchase some of both? And I don't know when you're going to build some, but you're doing the assembly with the house in China, isn't that right, Dave?
That's what I have been doing, and that's what I was planning on doing. There was some discussion of other alternatives, but for now, frankly, I haven't sprung for any of them yet. My real thought was to probably, when I get ready to build some boards that actually have the chip on them, I would buy some of the ones off of AliExpress, if I can get them queued into, if LTC whatever it is, LTC PCB will allow me to have those in their consignment category. They're cheap enough, just try a few of them and have some boards made with them. And if I have to throw them away, that's okay. But if they're, I don't know how to know categorically how to distinguish long term whether one is better than another, except by just using them until they die. And even that's a little involved. But buying, the minimum order of boards is ordinarily 5 from these Chinese board houses, and buying 5. Well, actually, the price has often been higher than that. I was seeing more like 190 to 210 on the 16-bit parts. And if those that were in stock at DigiKey last week, and I wasn't really in a rush to blow $1,000 for 5 boards. I don't trust my own design skills or board skills to the point where I want to blow $1,000 on that. But down the road, maybe so. But it does seem an awful lot. Those chips have never been, at the prices you see in China, on AliExpress. So there's something going on there. What those chips are, where they're coming from, either there's an immense surplus, which seems odd, or they're seconds, or they're recycled somehow. Something that drives them down to. I think that's cheaper than even the little preamp chip.
I have to point out that they could be counterfeit as well.
They certainly could, but
the Chinese do that.
Oh yeah, and
Analog Devices has had them.
I'm sorry.
Analog Devices has had their parts counterfeited before.
Have they? It would seem like a difficult part to counterfeit, but I don't know about such things really. I mean, they're pretty.
Yeah.
Isn't that pretty dicey?
They're very good at taking the layers off and just reproducing them.
Dicey, so to speak.
Yeah. Well.
Sorry.
So I don't know.
Yeah, they just carbon copy the layers.
Well, I certainly don't have any problem with using them for prototypes.
Yeah.
And I really can't see buying anything else for prototypes until I get awfully serious about making something. But another alternative would be to buy them here and have some other assembly shop do all or part of the assembly.
When we have a board to put them on, I would say we should get some of the cheap ones and try them out.
Yeah.
And if you look at the characteristics, you may be able to tell if they're truly legit or not. But one has to wonder what's going in the RX-888 as well, because basically they're selling that for the price of the chip alone.
Yeah.
Well, I'm pretty sure the RX-888 used one of those $15 ones. I mean,
I find that almost impossible to believe that they would be using. I was even to the point of looking at buying an X-ray machine the other day. I'm serious. The dental X-ray. If you don't buy one that's designed for chips, you buy just a little. You can get a little handheld digital. I mean, you probably have to be. They say that you need to be an authorized purchaser. Well, if nothing else, my wife is surely an authorized purchaser if I need. And I a Christmas present. You know, they're about $650, but they all have 60 or 70 I can't remember all the parameters. I was looking at comparing them around, but you know, I have a background where I know how to handle things like that too. But I probably can find a few lead bricks here and there. But it would be kind of a nice thing to have. I don't want to spend the price for the industrial sort of device that they sell. That's almost worse than the medical prices. But anyway,
It would be nice
it.
to have your own X-ray though.
Yeah. Well, I actually have thought about it in the past, and I have what's supposed to be a notoriously bad Russian tube for Remstrolung emissions. It is designed somehow, and if you put enough voltage across it, apparently produces a lot of nice 100 keV X-ray spectrum there. That's just about right for what. So I have that, but I haven't wanted to go there. Look like
Well, there's a lab. I've
yeah.
dealt with a lab here in Dallas that does X-rays like that. If you want to, I can get you a quote for. But I'm not sure what you're going to see when you do the X-ray. You really just see the bond wires and the chip outline. You don't really see a lot of detail in the chip itself.
Yeah.
So
When
my question.
When they copy the mask, they often copy the copyright notices and stuff too.
so what would that tell you? You could see that.
Just full whatever the word is. Just to let you know how I know this, I used to be an analog applications engineer for analog devices, and was present when they were dealing with counterfeits from China on a particular chip. It was an energy metering chip. It was an A to D, but it was for the power industry. And they were used in digital power meters.
I've read a lot about this, but I haven't heard all that much about it in recent times. You know, a few years they were really cracking down on it. But
now the interesting thing back then, and it may be the case still today, is that they couldn't sell them inside China. China insists on authentic parts, but you can sell them outside of China.
I see. That's interesting.
So they were selling them to India.
Of course.
India had an expanding power grid, and they were buying lots of power meters.
If it's not the same part, I think you'll see a difference in functionality right away. If you start comparing them electrically, you won't have to wait for what fails or doesn't. And if you really wanted to know, this lab can also decap them, remove the plastic, then you could photograph the actual top surface of the die on both of them. And,
well, at $15 a piece, I wouldn't be above doing that, you know, if I could do that. But that's
Dave, my question was actually, and maybe also Dave Larson can wait on that. What is a Tapper goal with a TangerineSDR? So are we looking into a finished product that Tapper will sell? I mean, because that also depends on what kind of chip you put in there, or if the LTC 2208 is the best solution in case,
Now, what's the chip we're using in the RF board that we've already done?
It's an analog devices chip. You mean Tom's?
Yeah, Tom's board.
That's a dual 14-bit. Well, Tom's here. He could talk about it, but
Tom should, if he's there.
If he's not,
Tom, are you there? I guess he's not.
Yeah, I'm here. I'm sorry. It's hard to
there he is.
Find a teeny mouse cursor on a microphone.
Oh, okay.
I'm sorry. I was writing notes. Go ahead.
Uh, we're asking what was in the RF board you developed.
I used a dual ADC chip. It is an analog devices. It's a dual 14-bit converter. Gosh, I'd have to look up the part number, 98 something. But my recollection when we spec'd it, it was a dual converter for about 40 something dollars.
That's a lot.
And it had, it's a 1.8 volt part, VCC, very low power. Hang on, let me rummage around the desktop and see if I can find the part number.
I have to step out, so if there are questions, I'll ask Dave to ask me tomorrow. He'll see me tomorrow, so
I will.
yes.
Okay.
So remember the thing you need to ask me and we'll get it back to the list.
Okay.
Would have been a 9648.
Yes, that's it. It's a 9648.
Yeah. Yeah,
Anyway.
so that's a dual 14-bit.
Right.
For less money. I'm not sure why the 2208 is going for as much as it is, because 16-bit converters have been around for a while.
Yeah, the reason we picked it, of course, it's a dual and we wanted a dual channel receiver.
Right.
But it was on a per A to D converter basis. It was, I thought it was extremely competitive price wise. At the time we picked it, 2000 or, 3 or 4 years ago, we picked the part, but it has a lot of digital test circuitry on the part. And that was very helpful in debugging the receiver module problems, and that we could go in and essentially have it put out digital ramps on the two outputs, disconnect the front end basically, and just generate digital ramps or generate, sliding ones or checkerboard patterns, things like that. And that was super helpful in debugging the interface connector problems.
I have one of those development.
I'm sorry. I'm sorry to poop on the party here, but the ADC and AC48 it sells for $300, Tom.
Well, we got
Let me see.
we got a price quote in the 40 something range.
Oh wow.
4 years ago. Hang on, let me double check.
Well, it might have been increased, the price recently, maybe they increased it.
Okay, it's the 9648 EP.
Oh, okay. Because I sent you the link. I looked. It was like way higher than that. Sorry.
Oh,
Yeah, it was my recollection right around $45.
I'm seeing it as saying $78 to $91 on this.
Okay.
That's the 105 part. We're using the 125 part, so that's on the order of $100.
Okay. Yeah, we got we have the 125 part on the samples.
Right.
And it was right around 45. So things, things have changed in 4 years. My grocery bill has.
Yes.
Well, I do have that development board. If we choose to go that direction, that I can play with as well as you, Tom. Not that I exactly know what I'm doing, and you've worked an awful lot of it out already, but I don't know whether you've ever been able to sort out the details of the Tangerine boards.
Yeah, Scotty has all the boards, and that's the last I've heard of him.
Okay, well,
I hope those can be sorted out soon, so we can use those boards.
It'd be nice.
I've been, kind of ramping up and so that I could do more testing and things here, tooling up a bit. as I didn't have much instrumentation, but some of it I'm not very expert at using. So, and that's a ways off anyway. I was just trying to stick to the schematics for now.
Yeah, my intent was to open the discussion, Dave, to see, where, what is the final outcome, where we want to get, eventually with Tapper, as a,
I get it. I get it.
it's not
my
technical, it's just end goal.
yeah, my understanding, as opposed to Nathaniel's or Tapper's or anything, was that we were doing this largely because we just didn't have schematics we could embellish or work. We didn't have a starting point. And if we had a library of starting points, we could more easily do whatever suited us as time went on. And then it's kind of evolved to the point where, well, let's try to make one or well, I have the developer boards right now, so I want to do some testing on those. But beyond that, we'll want to, be a lot of this. It seems like there would need to be a lot of discussion of what people want out of them, whether we're looking for a commercial product or something that is strictly a research support project. I can imagine situations where you might only want 5 of them or something because of some specific phenomena you had 5 locations you wanted to look at. But it's always nice to make them available to the public at large. And Tapper is a fairly easy mechanism for us to do that. But it was never, as far as I know, a plan for a big money maker for Tapper. But didn't want it to cost them anything either.
Yeah, thanks, Dave.
I'll probably order some of those AliExpress chips as soon as my next Social Security check comes in.
Can you buy them with snaps?
I don't know. Try.
You eat chips for them. They were potato chips instead.
Yeah. Maybe they're healthy chips.
Yeah, anyhow, for prototyping, I agree that $15 you can, something goes wrong, you're not.
Yeah. I've already got several boxes of throwaway boards, two sets at least of 5 each. That
Oh my gosh.
it was just easier to measure how things fit after I made them before.
I'm looking at Analog's listings for 16-bit 120 sample per second parts. They have 6 of them. Looking to see if any of them are dual.
There's another non-dual chip that is conceivably attractive. It's been used by several people on these sites and projects. I think the Kiwi used it. It's the 2224 or something like that. I don't know what, it's probably only 14-bit. How much of that last 2 bits do we actually get to use?
Very good question.
Yeah.
That is a good question.
The,
I've
the
always
answer
wondered about
according to
these
data
effective
sheet.
number of bits figures and why there's so much less than the
Yeah.
advertised number.
When I looked at the parts, the 22.8 was about 12.6 effective number of bits. And the 14-bit part that I was looking at was like 12.1 effective number of bits. And
So
so
why is
between
there such a, I've never understood the theory here. Why
effective
is
number
there a
of bits,
difference? Yeah,
the dynamic range is the signal compared to the quantization noise, right?
right.
And so the effective number of bits says that the noise and nonlinearity of the part is equivalent to some additional amount of quantization noise. And I'm not sure. David, do you know how they did that? That was my understanding.
What was that again?
The effective number of bits refers to the degradation of the quantization noise due to imperfections in the converter. And so
Yeah. And nonlinearities, basically.
right. So for example, if you had a perfect A to D converter, then it has no noise, but it has quantization noise equal to the 1/2 the LSB. And then if there are defects in the part, that equivalent quantization noise comes up or increases as a result. And therefore the effective range of the converter is reduced.
And why do we even keep those lower 3 or 4 bits? What good are they?
Well, that's why we went with a 14-bit part, because there was hardly any difference between that and the 16-bit part.
And there are cheaper 14-bit versions of the 2208 even.
Yeah.
Not
And
much.
us software guys, bust our butts trying to move all those bits fast enough for you guys, and then it turns out not all of them are even useful.
Yeah.
Well, you do get effective, improvements in there, but it is, what's really more limiting is your system noise.
That's what I was wondering. If is this all assuming a perfect environment?
Yeah, and remember, we're talking HF here, so there's a lot of actual environmental noise.
I can understand the part's degraded by any noise that gets into the input, and that's not the part's fault. I understand that part.
No, I'm not saying it's the part's fault. I'm saying that's what might actually allow you to use fewer number of bits.
Yeah. That I can certainly understand.
So that your noise level is effectively at the, say, 10-bit level.
Yeah. I've always wondered why everybody seems to be so gung-ho on smashing signals right up into the MSP when, you've got
It is a good question. And I'm not sure exactly how far down these 16-bit parts really do go. But I will tell you, I did a lot of work with audio at 24 bits. And guess what? The 24th bit actually is visible.
Really?
Yep.
Well, I thought 24 bits is really only used for mixing, right? In audio. I mean, import.
Oh, no. Good audio is reproduced at 24 bits. And in fact, at mixing, you're doing 32 bits a lot of time.
Oh, wow.
And we were
16 bits
making
already gives
120
you-
dB dynamic range converters and better. And you can actually see the 24th bit tweaking.
I remember when the CD first came out and suddenly you could hear the conductor breathing. You could
Yeah,
hear the
well,
rumble of
yes
the air
and
hailing
no.
system,
Yes and no, but 16 bits is not sufficient for the ear. The ear is a lot better than that.
Is it a situation where if you buy 16 bits, you get 14? And if you buy 14, you get 12? Or
That's, yeah.
Not really. I mean, you can make a very good 16-bit converter. And then
you can
it actually, there's crunchiness to it. I can hear quantization noise in a 16-bit wave.
Oh,
If
it's a
it's the
level.
right signal.
Sure.
Right. So the dynamic range peak signal to noise is the Bob sent a link, and Bing put it up on the screen for 1/10 of a second, and then you have to research it. So at any rate, yeah, it's what I said. It's just the imperfections expressed as an increase in the quantization noise. And that's what effective number of bits. In RF converters, I've not seen 16-bit converters much better than about 12.5 or 13.
So, okay, when you say imperfections, does this cause the quantization noise to vary with signal level?
It
I mean,
can.
kill the input.
There's a whole bunch of things, right? There's non-linearities, non-monotonic codes, non-linearities in the codes. There's even if you ignore noise, the codes, the digitization curve isn't exactly linear. It'll bend a little bit.
Right.
There's all of those kind of effects, which can be expressed as a increase in the quantization noise.
Okay, so what I'm getting at is, are those low order bits ever useful? I mean, are they useful low signal levels still?
Well, it depends on your signal. And the thing is that we're trying to basically digitize the whole band.
Right.
0 to 30 megahertz. So any nonlinearities is going to cause you intermod.
Right.
So you really do want as good a converter as you can get.
Well, of course, you always do that, but
so the question is, if you were actually band limiting the front end, you probably could get away with less. But given what we're actually doing with it, I'd go for as deep bits as we can do. The differential here is about 14 bits dual channel to 16 bits single channel. The pricing is about the same.
Given all the thermal problems you've had, do you really want to double them by putting 2 in 1 chip?
They can do a pretty good design for a dual.
Yeah, the newer, remember the 2208 is a pretty old part, and it dissipates a lot of power. That when I looked at the 9840, whatever it is, it was in a much newer process, and its power dissipation for a dual is something like 1/5 or 1/10 the power dissipation of the previous gen part. So big, it's a 1.8 volt part in it. When I ran it on the receiver board, it ran stone cold.
Oh, well, I mean, another argument for having dual channels is if the imperfections are matched. That might be one argument.
This is interesting. I just found a 2-channel 16-bit. Oh, it's 20 megahertz. That's why. Low sample rate. I got to get this. I'm looking at the selection table, and I need to put the sample rate up here.
Yeah, the reason we used to dual, of course, is we wanted to have synchronous sampling on 2 channels for various things. And the advantage of 14 is we stole the most significant bit, and the FPGA replaced it with a GPS edge for time stamping the ADC samples, which, of course, if you're going to have real high accuracy stamping, that's probably the best place to put it.
Why not just steal the lower bit?
Well, we didn't steal any bits on the 14-bit part. The 2 MSBs aren't wired up, and so we just we ran over range into bit 15 and PPS into bit 16.
Remember bit Rob signaling? And
Oh, yeah.
64K. I just remembered all that. Yeah.
Oh, gee, yeah.
That's why we had 56K links instead of 64. Remember that?
Yes.
Yeah.
Yeah, we stole a bit. Bit one, the DS1s stole bit one for framing signaling.
The low order bit is still a low
Yeah.
order bit.
Yeah, not zero.
Every
They stole-
sample either. What?
Yeah, they didn't steal bit zero. They stole the next bit up.
Really? I thought it was bit
Yeah, I
zero.
think so. My memory's getting fuzzy. That was too many years ago.
But they didn't steal every one. Of course, you wouldn't know which one was stolen. So
Yeah, they only stole like one bit out of every 8 samples,
yeah.
but you couldn't trust that it was there, and so it destroyed the throughput of data modems.
Could have used coding, but it was too early for that.
Yeah.
And we
What do
did
you
something
want?
similar in CDMA. You know, we robbed bits for power control, but in that case, it figured, the coding will fix it, and it did.
One thing that bothers me about their selection table, the pricing is all at 1K level.
Well, yeah.
They're trying to, but there's a part, the LTC 2185.
I sent you a couple, Dave, yeah. And the 9650 can get to 105.
Yeah, these are 125 megahertz parts. There are a bunch of 105 megahertz. The LTC 2185 is a dual 125 megahertz. Does all sorts of different parallel interfaces. And it's 131 1K price. It's probably, let's see what they, want for that single piece.
Do we need that highest sampling rate if you're only interested in HF?
Well, I think we want to digitize up through 6 meters, don't we? 50 megahertz or better. That's what we've been designing to.
A lot has to do with whether you really want to have one antenna for all those bands.
Yeah, that's true. They're like
DigiKeys are different. Oh, sorry.
$175, $200 part. So that I'm just thinking if we do want multi-channel, we could be looking at that. But that's comparable to what we've put in the RF card, but a 16-bit version. Now, on the other hand, working with the 2208, we know the interfacing to that gets us part way, and then, if we want to go beyond that, we can start looking at different chips.
Yeah, the 2208, there's an awful lot of examples to draw on. That for me has been nice, though they almost all seem to do it exactly the same way. They just use the data, what's in the data sheet, at least, in the app notes. But I don't know. I always like the idea of dualness, of coherent stuff.
Mm-hmm. Exactly. Yeah, and
Now, David, if money is not an objection, the Flex Radius 6700 use dual AD 9467. I just put the link here. which are 200 mega sample per second, I think, or 250 actually.
And how do
Wow.
they use all
They
those
probably
samples?
you can get even FM radio probably with those.
Well, a lot of these you can get FM radio by doing undersampling.
That's true.
Well,
I do have.
the 22A can do that. I mean, it'll sample and hold up to about 750, I think.
Yeah,
Memory serves me right.
many of these.
What you just need are
Do that.
switchable bandpass filters
Right.
and the right flags for the software.
So yeah, if we want to adjust the HF band up through 30 megahertz, you could get away with a lower sample rate part.
Well, you need a little margin over that.
Right. But, an 105 mega sample part would certainly do it.
Yeah.
Some of the current pricing may be just anomalous too, still left over from the part shortages.
Yes, that's true.
I've heard
It also
said.
depends who you are buying.
Yeah.
Relationships count a lot.
I think I'm going to say 73. Thank you very
Yeah.
much,
All
everybody.
right.
Same here, guys. You have a good night.
Don't
Happy
eat too much
Thanksgiving.
turkey.
Yeah, you too.
Yeah.
Thank you.
73s.
Yep.
Yeah,
73.